Okay, so we'll begin this class by having a look at the power equation for lenses, not to be confused with the power equation from classical mechanics, which is the rate at which energy is spent or work is done. But in terms of power for lenses, what we do is that you must have heard of people saying that their power of lens is something like minus 1.75. Okay, or somebody would have said that the power of my lens is plus 0.50. So what do they mean over here? Um, well, the power of lens is defined in a certain way in your textbook. It's the capacity of the lens to bend the rays. Okay, so a converging lens will converge the lens more. If it converges the lens more, then you say that one lens has a greater power compared to another. So I have two converging lenses over here. I'll just go back to the main screen. So I have two converging lenses over here, and I am not sure if you're able to see. Maybe I'll get it a little closer. You can see that this one is thinner than this one. So the capacity to bend the light is more for this one because of the curvature being higher than this one. So we say that this one has, this lens has more power in comparison to this lens. And you can, I think, yeah, you are able to see the effect of that. So this one has more power than this one. So what is this power? Well, the power is used in order to uniquely identify the lens, which brings us to the question: why not use the focal length of the lens itself to uniquely identify the lens? Because for after all, if two lenses have the same focal length, then obviously their power is also going to be the same. Um, I'm not sure exactly what is the reason that people prefer the power of a lens over using the focal length of the lens to identify it. But I believe because in the lens maker's equation, there is something called the lens maker's equation, not to be confused with the lens equation that we have just studied. There, uh, just like in the lens equation, you see that the focal length, object distance, image distance, everything is in reciprocals, right? So because of that, I believe it becomes easier to talk in terms of the power of lens when you use the lens maker's equation. And also when you use multiple lenses together, that is, let's say, two converging lenses or a converging lens followed by a diverging lens or the other way around. Apparently, if you use two lenses of different powers closely together, if they are put closely together, then the combined power of it approximates to the sum of the powers of the two lenses. Okay, so let's say if this one is minus 0.5 and this one is minus 0.25, I beg your pardon, plus, it has to be plus because this is a convex lens, then you can say that the combined power of these two lenses will be 0.75. But what exactly, how do we find out what is the power of a lens? Well, the power of a lens is actually nothing but the reciprocal of the focal length. Okay, and what are the units that it is given for this? Well, power is measured in terms of diopters. So P is mentioned in terms of diopters. And focal length, of course, has to be then, not of course, focal length, it happens to be measured in meters. Okay. So one of the issues that we have in terms of doing calculations based on this, you will be asked numerical problems based on this, is that whatever the focal length of the lens that is given to you, you will have to convert it into meters. Typically, it will be given in centimeters, not millimeters. So you divide it by 100 to get the focal length in meters, and then power will come out in diopters. Symbol of diopter is capital D. So strictly speaking, what that means is that the unit of this power of lenses that we are talking over here is measured in diopters. Optometrists, ophthalmologists, when they do tests on your eyes and give you corrective lenses, what they are saying is your power is minus 1.75 diopters, but they don't say diopters. Although if they hand you out a prescription, you can look in the prescription slip. The unit will be mentioned over there in capital D. The capital D is diopters. I also incidentally found out that the diopters is not a SI unit, interestingly. So in the SI unit of derived units, you do not find diopters for power of lens. Uh, and so therefore, what is the power of lens in terms of SI? Since it is 1 upon F, and F is measured in meters, the unit for power of a lens in terms of SI units will be meter inverse. Okay, so that's one funny thing. Although you don't have to know this for your syllabus. So let's just look at one kind of a problem. The problems that can be asked in terms of lenses are very straightforward. Um, and here is a typical problem. The power of a lens is given as minus 5d. You have to find the focal length and what type of lens it is. Okay, so let's just solve this problem quickly. The power is given as minus 5 diopters. Okay, and you have to find out what is its focal length and what type of lens it is. Well, the second part is easy because the answer comes out negative over here. The power is negative. That means the focal length will also be negative. So if the focal length is negative, then you know it's a concave lens. Let me just go back again to the whiteboard. So we know the formula. Write down the formula as the first step. Power equals 1 upon F. Okay, so power is already given minus 5. So that is equal to 1 upon F. So rearranging the equation, you write F is equal to 1 upon minus 5 or minus 1 upon 5. And that gives you the answer 0.2 minus 0.2 in meters. That's very important over there. You have to write it in terms of meters. So therefore, you can leave the answer as it is, minus 0.2 meters, or you can convert it if they ask you to. You don't have to do it yourself. If they ask you to, you can convert it into centimeters and write it as minus 20 centimeters. That's entirely based on what the question is that is being asked. It's typically a 1 mark question, a very straightforward application. Just take care of the symbols, if there is a negative symbol in particular. Otherwise, there should be absolutely no problem answering these kinds of questions. Okay, so I hope that is clear. It's a very simple part of the syllabus, and almost every board paper there would be at least one question, either in the optional part or in the compulsory part. So it's good to be prepared with answering power of lens equation types of questions.